everyone to this joint S Training Roses webinar. I have the pleasure to introduce today someone that most of you know very well, James Reade from the University of Reading, where he is a professor of economics and head of the Department of Economics. His research is on applied econometrics, but he's particularly interested in sports. And as such, he has, since the COVID pandemic started, been organizing the ROSES seminar, which stands for Reading Online Sport Economics Seminar. And so today we have joined forces to hear his talk, which will be about exploring entertainment utility from football games. Thank you very much, James, and please, the floor is yours.
Thanks very much, Christoph, most of all. A very kind and generous introduction. It's a pleasure to join forces again. We've joined forces previously with the S Training and the Roses talks. As I said previously, if you are interested in being involved in the Roses talks, please do feel able to get in touch with me either through the chat here, or you can find my email address online. The Roses talks tend to be on a weekly basis. We've been running them for 2 years now. In fact, 2 years pretty much to the day. We began on, today's the 25th, we began on the 27th of March 2020, and so this marks 2 years of meeting online and sport economics research seminars. We're obviously now starting to move back towards things in person, although my personal experience is that a lot of research budgets aren't quite what they were pre-pandemic, and as a result, there may well be plenty of scope to carry these kinds of seminars on for the foreseeable future, and it's also added something of a different dimension to certainly our interactions in the field of economics. And I appreciate that I'm an economist here amongst people from various fields. I'm very happy to be there in that sense. And obviously, if I slip into economics jargon and things that don't necessarily make sense, my apologies. But equally, also a lot of the economics behind this is more of the work of my co-authors, and I've certainly spotted that Tim is here, Tim Pawlowski, and I'm hoping that Philip is here, because Philip's the brains behind a lot of the technical computational aspects of this, and so at that point I will certainly appeal to him for any difficult questions that come along. But as said, the online seminars have provided us with something, and so likelihood is we will carry on with them. But if you do want to be involved, please do get in touch with me. So this work is entitled Exploring Entertainment Utility from Football Games. I've already mentioned Tim and Philip. It's also jointly with Jim Battista Rossi and Duraj Rambakasing as well. Let me move to the next slide if I can. There we go. So what it's all about essentially is something that economists refer to as the uncertainty of outcome hypothesis. I've said there it's ubiquitous because in many respects it is. It's well and truly believed that it exists. I've talked to people who are involved in the design of sporting competitions, and it's well and truly believed that it exists. And it makes sense as well that if something's a foregone conclusion, you're not going to watch it. Whereas if something is very uncertain, you're probably going to watch it. However, by and large, academic studies don't support the uncertainty of outcome hypothesis, at least in terms of looking at very what are reasonable sources of data, but nonetheless somewhat limited in their nature. Classic studies have looked at stadium attendance numbers and tried to consider the extent to which, say, pre-game betting odds, to give you a measure of the likelihood of outcomes, how they influence attendance at the stadium. More recent contributions have looked at other ways of trying to measure this, looking at, for example, television viewership figures, because of course they're less constrained by the size of the stadium. And there have also been more behavioral contributions as economics has embraced the behavioral revolution, thinking about different aspects of that fan demand. Why does a fan demand to attend a football match? And so things like reference dependent preferences, and to some extent elements of habit persistence. Fans will go to games kind of regardless. They have allegiance and other preferences aside from simply the level of the uncertainty, or perhaps they don't even want that much of a level of uncertainty. And recent formulations have moved in the direction of concepts or emotional cues, such as surprise and suspense, and we're going to talk a bit more about them as we go through. What we're doing in this paper is we're adding two ingredients to what's already been done, building on the literature before us, because we, via using social media data, are able to consider the sentiment of fans, happy, sad to some extent, the extent to which we can measure that. And we're also able to think about a way of trying to split the audience into different groups. So often in more kind of theoretical takes on how fans access or demand sporting events. Sometimes it's noted that there will be kind of couch potato or neutral fans, and there'll be fans of either team or any of the teams that are participating, and they have very different preferences. And I guess I'm going to motivate that a little bit by with my next couple of slides, which are a couple of examples of where I've suffered suspense in recent times. And so this is a game I attended with my own team, and so a nice picture there. You see not a particularly full stadium, and so no capacity constraints there, but nonetheless, the point is this was a game, an important game between two evenly matched teams, and the scoreline was 1-1 going into the 94th minute of 94 minutes. When Carlisle United scored a winning goal, and the level of suspense obviously was particularly high. I wear one of these Garmin watches, which records my heart rate, and I've noticed in the past that there are fluctuations that are consistent with the 45-minute intervals of football matches. Suspense affects us. And if you think it's frustrating enough to watch your own team lose the last kick of a football match 1 week, I then managed to end up the next week at another match where, again, exactly the same thing happened. And in the 96th minute, there was a goal. And again, the suspense was building throughout. If you think about suspense as what's going to happen next, well, any kind of goal, and particularly towards the end of the game, any kind of goal is going to change the outcome of the game. And so the suspense builds and builds and builds, especially if the game is goalless or level for a long period of time. So suspense, one particular emotion. Surprise, change in the outcome as things are going along, and shock is more of thinking about how events have changed relative to what you were expecting prior to the game beginning. And so just to flesh out what I've been saying so far in a little bit more detail, a couple of references there to the seminal economics contributions about this uncertainty of outcome hypothesis, Rottenberg and Neal. And on a practical basis, these arguments form the basis for an awful lot of policy when it comes to sport, cross-subsidization of sports clubs, and labour and market interventions, the restriction on player or labour movement between teams, between leagues, all around the world. And so it's an important concept, and hence, given it's important, given it plays a role in these kinds of restrictions on labour movement and differences in terms of financial returns to teams, therefore, we feel it's quite important to test this uncertainty of outcome hypothesis. And as mentioned, there have been plenty of attempts. They often tend to involve some kind of expression similar to what is here, linear regression type setup, where you've got attendance between two teams, team I, team J, time T, and you look at some measure of the pre-game or the probability of the outcomes, usually bookmaker prices, and you look at the level, if you like, and the square, first and second order terms. And in expectation, if the uncertainty of outcome hypothesis was true, you'd expect to see beta 1 was positive and beta 2 was negative. By and large, most applications have found the opposite. And there's a study here by Dominic Schreier and co-authors to that effect. So most studies don't find the uncertainty of outcome hypothesis. And that's what economists often refer to as a puzzle, something that doesn't necessarily make sense. They propose the theory, and then the real world throws a curveball. And so what do we do about it? Well, we try and explain the difference, try and adapt theories that we have, build in different explanations. And Tim, in a previous paper in 2013, reflected that, well, subjective uncertainty, the uncertainty that we have as fans, when I turn up to that Oldham Carlisle game, my expectation is different to what the bookmakers' expectations are, and perhaps what some kind of statistical model or econometric model might tell me. That said, in a follow-up paper, Tim with co-authors found that home win probabilities based on betting odds are very highly correlated with the perceived home win probabilities by fans. So as a result, that's not necessarily a particularly strong explanation. Dennis Coates, who's also on the call, and co-authors, including Brad Humphreys, in 2014, proposed a model that distinguishes between, builds in these behavioral aspects that I mentioned, reference dependence or gain loss utility. The fact you may gain more or less satisfaction from a win that you didn't expect than the desperation you feel when your team loses in the 96th minute. So the unexpected loss is much, much worse. And Peter Dalton has worked looking at the similar thing, where they find that, again, that you've got the impact of a loss is different from the impact of a win. And in a follow-up paper, Brad Humphreys and Zhao tested a model based on that, which doesn't enable the absolute identification of the size of these kinds of effects, but does enable via restrictions on the size of coefficients to consider different theories regarding preferences for outcomes. So game uncertainty, the preference for home wins. I went to that game hoping that my team, the home team, would win, and this loss aversion or gain loss utility. Oh, I skipped straight on to the data. So I think I probably had another slide that I wanted to put in there to develop a little bit more a literature that's been developing in recent years by Eli and co-authors. And so I've not got that reference on the slides because I've missed the slide out. Thinking about emotional cues, aspects of the experience that motivate us, and so hence this surprise, suspense, and shock idea. So it is, and our response is potentially more to these emotional cues within a game and those emotional aspects of a game that mean perhaps we go back because we enjoy the highs of the positive surprise when we're at a game and the impact, the way in which a goal affects us. And that's a literature that then developed further. I'm pretty sure I've not got the slides here. No, I'm not, because I go into the data. That literature, the surprise and suspense idea. So the idea is that the surprise is your expectations now versus your expectations very recently. A minute previously is a common way of measuring it. That's the surprise. If there's a big change in there, perhaps because there's been a goal for your team, you're plenty much happier. And that surprise is a surprise in things have happened recently. The suspense, as mentioned, is this idea of what could change if something happens in the next few moments. And so there's a paper by Bitzero and co-authors. I'm absolutely getting the name wrong, and I will. And my apologies for not having the slides, the reference in the slides. But they look at Wimbledon tennis and look at TV viewership figures and try and measure using betting data these ideas of suspense and surprise, because you can look at in-play betting data. In-play betting has existed now for well over a decade, and so you can look at those prices and you can make an argument that they are relatively good reflections of what the actual probability is of the outcome at any given point in a game. And then you can measure them and you can see whether TV viewership figures adapt to those measures of surprise and suspense. Tunde Boraimo and co-authors have looked more recently at the Premier League, 540 matches in the Premier League, and added the concept of shock. So the surprise is minute to minute, things change, but then the shock value would be, well, how surprising is this relative to what you expected back at the start of the game? And so the way in which that's operationalized is that surprise, you look at the current minute of action relative to the previous minute, Whereas with shock, you're looking at the current minute of action and what your expectations are regarding the outcome and what you expected back at the start of the game. And they look at this for the Premier League. And again, they find that obviously these, well, I shouldn't say obviously, but these three emotional cues play a significant role in explaining TV viewership figures. Again, TV viewership figures for the competition. So what we have is similar to Boimo et al., which is we have the Premier League as our setting. We have the season 2013-14, and the reason for that is the availability of the data that we're using. And we have data from Fraxoff, which provides us data from Betfair's betting exchange. So an exchange where people buy and sell bets rather than a bookmaker where the prices are set by the bookmaker itself. The prices on a betting exchange are determined by the demand and the supply for bets. And there's research, which I've got one reference later on, that suggests that these prices are reasonably good reflections of what the outcomes are going to be. And then we've got data from Twitter. So Jean-Baptiste Durage and myself got data via Twitter's data grant scheme a number of years ago. And we got 3 seasons worth of tweets related to Premier League football teams. And so we've got the betting odds. We've got, alongside that from Fraxoff, we get the in-game events. So what's taking place in the game? Was there a corner? Was there a shot on target? Was it saved? Was there a substitution? Did the game stop at that point as well? Because when you get betting data, it has a timestamp about what happened when, but you don't necessarily know exactly when the goal went in, exactly when the starting whistle went and the final whistle went. And so we've got the in-game events and we've got the in-play betting odds. And we've got all the tweets for Premier League football teams over this time period. So talking you through the data in turn, we'll start with the betting data. As said, it's Fraxoff data, it's best back and lay prices. And what we take is the midpoint between the back and lay prices weighted by the available volumes. So back is when you're buying or purchasing a betting contract, and lay is when you're selling the contract. Normally, if you go to a bookmaker, you're backing a bet, and the bookmaker is laying the bet or selling you the betting contract. And again, a common approach is to take this midpoint to reflect exactly where the market is, rather than what people who are trying to sell bets or buy bets are necessarily pricing them at. Again, conventional thinking about betting markets, there's an overround. That is, if you were to work out the implied probability, a conventional approach here is to take the reciprocal of the price, decimal odds. And if you do that and sum up the 3 outcomes, home, draw, away win, home, draw, and away win, home win, draw, and away win, you'd find that the probabilities sum to more than 1. And so what we do so very simply is divide each probability, implied probability, by that overround, so 1.1 or whatever it is, which is often referred to as the checksum approach for doing so, and that gives us a set of probabilities. And there's some summary statistics here. So you've got the prices here, so decimal odds. So the mean is quite high because the maximum on Betfair is that you can have decimal odds of 1,000. But as you can see, the percentiles, the 25th percentile is 1.2, even the 75th percentile is a long way below the mean. So a highly skewed distribution. As such, we often think about these probabilities, and the probabilities here, the probability for the home win, average of 0.46 or 46%. For the away win, average of about 24%, and for the draw, average of about 24%, and for the away win, about 30%. And for reference, in this particular season, 2013-14, 47% of matches were home wins, so not far away. 21% were draws, again, not far away, and 32% were away wins. Evidence of the home advantage that's often studied in sport. As mentioned, Fraxoff also provides this detail on the events taking place in the match. And so what I've done here is I've simply summarized how frequent these events are. So these are essentially the events that they summarize. You've got goals, attempts on target, or sorry, attempts on goal, whether there was attempts to hit the woodwork as a particularly notable type of attempt on goal that isn't a goal, corners, cards, yellow and red cards, substitutions, offsides, saves, and 1 and 2 refers to 1 being the home team, 2 being the away team in a game. So you can see, and these are, this is 380 matches, 100 plus minutes when taking into account all the minutes in a game. And so you get about 43,000 observations. And you can see that goals were about 1% of those observations, more common, of course, than shots on the woodwork, less common than shots themselves. And corners being fairly frequent, again, more for the home team than the away team, more away cards for the away team than the home team, and so on. But these are the events in match that we might wish to look at and consider how they might be influencing fan behaviour as well, or fan behaviour as dictated through social media. And so moving on to formalizing, we've got the betting data, and so formalizing those emotional cues, we follow the Barango et al. Paper, steal most of their notation, at least for these slides. And these are the measures of surprise. Surprise is from minute to minute, so we've got the probability of a home win at time t, so the current moment, minus the probability of the last minute of the home win. So this is a measure of how things have changed in the last minute. And given that we're talking about football, we've got the possibility of a tie or a draw, and so we add in that possibility as well. So essentially, how things have changed in the last minute. Shock instead takes the P0, the probability at the start of the game, pre-match odds, rather than the minute previous. And so you've got 2 measures of surprise, shock, how things have changed, and the larger the size, the larger the change from expectations at the start of the game or in the previous minute. Suspense is involves a little bit more work. Not least, it involves an additional probability, which is the probability of either team scoring in the next minute. So the idea of suspense, again, is how things might change if something happens. So if my team goes and concedes that goal in the last minute once again, it's going to have a big effect. And so you can see what we've got here is we've got the probability that the home team scores and the probability that the away team scores, and then the impact of that on what the outcome would look like. So the probability of the home win, draw, the away win next minute, given multiplied by the probability that the team scores in the next minute, minus the current probability. So how much of a change will there be if that happens, and how likely is that to happen as well? And this involves obviously a forecasting exercise, because we've got t+1 and we're only at time t at any given point. And so what's the likelihood of these kinds of changes taking place? And so we've got a simulation exercise based on previous patterns of goal scoring, and therefore accumulating to outcomes to work out or to generate a measure of suspense. So we've got to generate both the probability that a team scores in the next minute, and then we've got to forecast what therefore the impact would be on the outcome probability. And I mentioned this earlier on, we're using bookmaker prices, or actually betting exchange prices, I should say, for these measures of expectations. And there's extensive literature. I'm naturally referring to one of my own papers here to suggest that this is a reasonable approach to take. And so just kind of giving you some sense of what the data looks like. These are all 380 matches, or I think minus 1 or 2 of this particular season, and these are the measures of surprise, shock, and suspense. We'll look at them for one particular match in a few moments, but this is over the whole season. So what we've got on this plot is the black is the measure of surprise, green is the measure of suspense, and red is the measure of shock. And so you can see on average that the shock measure is larger, and this may explain some of the relative size of coefficients later. But also the relative size of the average here relates to the fact that surprise is a measure, as you'll see, which jumps up and down around a goal because it only changes with the previous minute. Whereas the shock, which is in relation to the start of the game, once a goal happens and changes probabilities, that new level is maintained. So that may explain, again, some of the differences that we observe here, but this is more just to give you a sense of this is kind of what the numbers look like. And I've put a grey line just to signify that these are individual matches. And I know that the font's far too small for you to see what each individual match was, but also, again, just to indicate that they are pretty much all there. And then down here, there's again some summary statistics, the mean, and you can get a sense from the percentiles of the nature of the distribution, especially of shock. That there were some particularly shocking events that took place, but then, surprising events that took place, but then things dropped back down again. In terms of the Twitter data itself, this is again looking at these 380 matches and looking at the number of tweets in any given match. And what you can see is significant variation. Red is the away team's tweets, and black is the home team's tweets, as assigned, and I'll come back to this in a second, as assigned in terms by the Twitter handle used or the Twitter hashtag used. But you can see again some matches with tens of thousands of tweets and some matches with very few. Obviously, this is 2013-14, so this is now 8 years ago, and we imagine that these numbers might be larger now, given that perhaps more people, more sports fans use Twitter, but it's certainly clear from these numbers that plenty of fans were using Twitter back then as well. And our data amounts to 19 million unique tweets associated with teams via, as I said, hashtags, but also the handles as well. So we've got the case of Liverpool, and what the data looks like is essentially a file full of tweets per club per match day. So a spreadsheet, CSV file full of tweets for a club on a given match day. They're tweets that mention these handles. And so, of course, that doesn't guarantee that these are fans of the team. But nonetheless, you've got FC Liverpool or contains any of these. So LFC is Liverpool's official account, and then various unofficial accounts that are out there. And these are handles, often referred to as handles. And then these are hashtags down here. So hashtag LFC, hashtag Liverpool, hashtag YNWA. You'll never walk alone if you're not familiar. And then down here is a couple of examples of the tweets themselves. So I've got one that looks like it probably is from a fan. So excited about the game. We're going to win the league. LFC proud Scouser as a Mancunian. I find that idea quite interesting. But nonetheless, proud Scouser, obviously, or not necessarily obviously, but quite likely a fan of Liverpool. And then this is a tweet. And that's also, to be known, a tweet sent just before they kicked off a game against Chelsea on the 27th of April, 2014. This is a tweet later on when the game is finished, which is RT retweet, and the tweet is simply LFC LOL, and that is, I'd say almost certainly that's not tweeted by a Liverpool fan, not least because Liverpool lost the game in quite a crucial manner for their hopes to indeed win the league. So, as mentioned, 19 million unique tweets, 380 matches over the season. And we calculate from that sentiment. And I mentioned at the start, this is where Philip did the work. The way in which we calculate sentiment, we've calculated them using a random forest regressor trained on data from Stanford's Sentiment Tree Bank. And this random forest, which is a supervised learning model, is an ensemble of decision trees popularly used for natural language processing. And there are obviously arguments in favor of doing so. This random forest shows how important individual features are in determining outcomes. We've used Python to do this, and as said, if you do have questions on that, I'm hoping that Phil will be able to answer them later on. But this addition of sentiment is something that we're able to add over and above TV viewership figures. Twitter gives us that possibility of determining, whether those tweets are happy tweets or sad tweets. stress tweets, worried tweets, and so on. So natural language processing we're able to use to do that. And this is, again, similar format to the previous plots. This is just to give you a kind of a graphical sense of what this sentiment measure looks like. And so you can see it's bounded between about 12.8 and 14, where higher means more positive sentiment. And here you've got the black dots for the away team's sentiment, sorry, the black dots for the home team fans' sentiment, at least home team tweets that involve the handles or the hashtags of the home team, and red dots for the away team. And so that gives you a sense of the data again over the entire season. The additional thing that we're able to do with this data, which is quite, I think potentially again quite interesting, is that we can try and classify users into whether they are casual or whether they're neutral, if you like, couch potato fans just observing the game and therefore mentioning a team because they're watching that game and they don't support that team. And of course, fans of the team, and potentially also Twitter users that really dislike a particular team. Because we can look at sentiment, variation in sentiment in and around football matches. We've got 380 football matches, 38 for each team over this time period. And so we can look at what a fan's post-game sentiment looked like, in particular when a team had won. Okay, and so we identify, or we attempt to identify fans if we look at if we rank their top post-game sentiment measures, which are attached to a team, remember, because we've got tweets for a team per match day. And if we look at the top 5, and a team appears at least twice, we class in the top 5, we class that that person as being a fan of that team. And again, it has to be, at least at the moment, it has to be that the team in question has won. So if we're looking at, we could look at these numbers. So we've got the numbers here. We could look at, say, we find a 15 or a 16 for the fans' post-game sentiment. And it could be that that team there is Man United, but they've lost. So this person is happy because Man United have lost. So we have to, at the moment, we're just considering when the team has won in order that we don't mix together, if you like, fans and haters of a particular team. And a previous iteration didn't do that and classed me as a Man United fan, which was particularly problematic. But as I said, for the moment, we're identifying fans, but we hope to be able to think about identifying more neutral fans. Perhaps these variations doesn't correlate with outcomes of any team, and also those fans that particularly hate a team, like I'm not particularly fond of Man United, for example. But these, the whole project is, of course, work in progress, but this in particular is most certainly a big part of the work in progress. And so if we do that, if we try and identify the supporters on Twitter of particular teams using that method, here is what we get. And so again, it's quite small, but the biggest group of fans are the fans of no team, which again makes some sense. I, for example, tweet on Premier League outcomes from time to time. I'm not a fan of any of these 20 Premier League teams from that particular season. Some of the teams that are now in the Premier League weren't in the Premier League in this particular season, and as a result, it's not totally surprising. There's quite a lot of fans of no team that was in the Premier League in 2013-14. What we've got is Liverpool, Man City, Man United, Chelsea and Arsenal have the most fans, traditionally the most successful teams, the teams here with Premier League title wins in previous seasons. And so that gives a sense that the measures reasonably capturing to some extent fans. This is a scatter plot of the average attendance in the stadium for these teams during that particular season and our estimated number of fans. This is the log relationship. And you can see that it's reasonably collected around the line of best fit. Equally, we've looked at the actual number of followers of the official feeds for these 20 teams now. Again, it's not perfect because we're looking at the number of followers of these teams now relative to 2013-14. But you can see that again, the collection of points is reasonably close to the line of best fit. So it does suggest that we've got a reasonable measure of fans of the teams. I mentioned a robustness check was whether or not I was deemed to be a Man United fan, which I'm not, according to this procedure now, thankfully. Another robustness check is that LFC LOL tweet, because you can't imagine that many Liverpool fans are going to tweet that particular tweet. And so this Liverpool-Chelsea game, there were 214,000 tweets. And of those, 43% were by users that we identify as Liverpool fans. And of the 5,000 users that tweet or retweet this LFC LOL tweet, just 2.5% are Liverpool fans, which seems like a reasonable outcome. And so just to kind of, again, scope out what these measures look like, this is a particular game that was notable again for the outcome for this particular season, where Liverpool were playing Crystal Palace and Liverpool raced into a 3-goal lead, but they were pegged back in quite spectacular fashion in the last few minutes of the game. And so these are the probabilities as per the midpoint between the best back and lay price from Betfair during the match. Red for Liverpool, blue for Crystal Palace, and black for the draw. So starting at the start of the game, Liverpool were significant favourites, scored, the probability jumped up from 70% to about 85%, scored again to go 3 goals up, essentially a probability almost at 1. These vertical lines are the goals going in. And then we've got the 2 goals that Crystal Palace got back, and Liverpool's probability adjusts down. It's still high 80s, that's about 90%. And then the 3rd goal goes in, which changes the outcome. And then the probability slumps from about 90% down to about 20% and sharply falls down to 0 as the game concludes. That 3rd Crystal Palace goal was in the 88th minute, so there wasn't very much time left after the goal had gone in. And additionally, the probability of the draw, the outcome that occurred, that jumps from being at about 10% to 70% and quickly moves up towards 1 to being a certainty, which is the outcome that occurred. So then the measures of surprise, suspense, surprise, and shock. We've got the solid line is suspense, and you can see that the suspense essentially is 0 when Liverpool are 3 goals up. Excuse me, but very quickly jumps up when it gets to 3-2 and jumps up further when it gets to 3-all, because any goal at 3-all changes the outcome. At 3-2, a goal for Liverpool doesn't change the outcome, whereas any goal at 3-all changes the outcome, so the suspense is considerably higher. We've got the measure of surprise. So again, this is the change from 1 minute to the last minute in terms of the match outcome probabilities for the home win, draw, and away win. You see a spike at the first goal, a spike at each goal, and although not too much of a spike at the goals, certainly the goal for 3-1, since there wasn't really much of an effect on the outcome probabilities, but then there was for the goal for 3-2, and then a huge spike for the goal for 3-all. So this is what I mentioned by this being a distribution that's got lots of very small numbers and spikes, and so hence it's a very skewed distribution. Then the measure of shock, which is where you compare what's happened at the moment to the pre-game probabilities. And what you can see is that is relatively low, but then shoots up towards the end, because at this point Liverpool are expected to win. And so therefore the differences between those probabilities at the start and the fact that Liverpool are looking likely to win, but then as the draw becomes the outcome that's going to happen, that's a shock relative to what was happening at the start, and so that increases up into its maximum observation. In terms of Twitter users, these are the tweets during that game. So the black line is the total tweets recorded for Crystal Palace and for Liverpool during the game. As you can see, spikes after the maximum well, not necessarily the maximum, but the attention points. First goal goes in, lots of tweets. The 2 goals go in to make it 3-0, lots of tweets. 2 goals go in, make it 3-2, interest, and then 3-all, lots and lots of interest. And then the light red, or the normal red and normal blue lines, are all of those tweets that are associated via a handle or a hashtag with the team. As you can see, there's a big spike up, particularly in Liverpool tweets, after the game becomes 3-all. Now, I know that if I was a Liverpool fan and that had happened, I wouldn't have been tweeting. I would have been, somewhere else completely, like I was when my team had gone 2-1 down with the last kick. And what you can see is if we try and look at the fans that we identify as Liverpool fans, this is the dark red line, you can see that there's a little bump up there, but the vast majority of the people tweeting are the guys tweeting LFC LOL. So those are the guys that are taking satisfaction at Liverpool's unfortunate turn of events. And with Crystal Palace, you say again, likelihood is that it's mainly people taking an interest in the game, not because they're Crystal Palace fans, and therefore they're mentioning Crystal Palace in association with Liverpool for this particular game. And so if we look at the Palace fans, not really very many of those guys tweeting, even when they just turned around an outcome in a remarkable game. That's the sentiment as measured. And so this is sentiment throughout the game. And again, we've got the normal blue, normal red is all of the tweets. And then we've got the ones that we identify with the team itself. And so what you can see is that there's a turnaround as things move. Well, I guess you can see that, first of all, Liverpool fans are relatively happy when they're 3 goals up relative to what they were, but not massively happy, which perhaps reflects the fact that there's still tension. There was still tension. Liverpool were uncertain to win the title at this point because of their loss to Chelsea. And so they weren't necessarily jumping around and celebrating in the streets. But then when the goals go in, the sentiment drops down, and the sentiment of non-Liverpool fan tweets is higher than of Liverpool fans that we've identified. And so, in terms of our methodology, trying to make sure I wrap up not too distant a future. What we're doing is we're following again the Boimo et al. Strategy, which is to look at some kind of measure of fan response or supporter or consumer behavior response to these emotional cues, in particular suspense, shock, and surprise, for a game I, match I, and minute T of that match. We're including minute and match fixed effects, and we're including also potentially, as Boimo et al. Do, some additional measures associated with the events in the game rather than the emotional cues in the game, and measures associated with the state of the game at any particular point in time. What will we look at? Well, we can look at the total number of tweets associated with a match. That's therefore not thinking at all about sentiment. And then, of course, we can look at home and away fans. Home and away fans is a little bit arbitrary. So what we can do is, again, once we've identified the fans of a particular team, we can then look at the fans of a particular team and try and consider the fan responses rather than the general, we're mentioning Liverpool as a Twitter user type responses. I've mentioned that X includes events rather than cues, scorelines, total goals, and raw probabilities. Again, the latter two is what Boimo et al. Do as robustness checks for their results. Okay. The final thing I just want to say that I'm particularly interested in. So I'm going to look at the total number of tweets, and then we're going to look at the sentiment of tweets, and then we're going to look at by fans identified with a particular team. And the final question that I'm particularly interested in, but it's not really necessarily an economic question, is whether all fans are actually the same or not. So if you ever spend any time talking with football fans, they believe that certain fans are rubbish. You know, Everton fans are always really quiet, things like that. It's not obvious to me that's the case. My kind of take is, well, most fans are pretty similar. They're all human beings after all. And so what I'm kind of interested in doing this research is the extent to which all fans are really all exactly the same. Do they respond differently? And so I'll try and give us a little bit of an insight on that. And now my apologies that these numbers are a little bit small. I hope you can see them on your screen. But what these are, this is the log total number of tweets, where I've added a tiny number because there are minutes where there are no tweets for some teams, the smaller teams. So I've added 0.000001 and then taken the log. There's almost certainly better measures. And again, let's say this is more work in progress, and we're happy to take suggestions. And this is a range of regressions looking at this, but adding in different categories of variables. So the top panel here, if you like, these, oh, it doesn't work. Does that work? Okay, well, goal down to substitution. These are events in the game. Goals and substitutions, if you just look in the first column at those events only on the total number of tweets, you can see that goals and substitutions are the things that generate interest. Not really surprising, really. You want to moan because someone's been taken off, or you want to express excitement because somebody's been brought on. The squared difference is the difference between the home and the away probability. So it's a measure of essentially a different measure of competitive balance. So again, going back to these traditional measures. And I guess if you are thinking about the uncertainty of outcome hypothesis, you might want to see some kind of negative coefficient here. And then the probability of the draw as well. And then the state of the game in terms of the total number of goals is like that will influence the total number of total amount of activity of people talking about the game. And potentially, again, competitive balance-wise, people may well be less interested to talk about the game if it's a foregone conclusion because the goal difference is particularly large. And then finally, down here, the bottom panel are surprise, shock, and suspense measures. And so what we do is in columns 1 to 4 is progressively add these additional variables. So if we add in these probabilities, we see that doesn't really affect anything in terms of the match events, and we have a positive coefficient on both, somewhat conflicting. And then we have, when we add in the third column, total goals, you see again, more goals, likelihood is more people are talking about the game, interested in the game. Then finally, we add in our emotional cues, so surprise, shock, and suspense. And we find that, well, if there's a surprise in the last minute, things have changed a lot. Therefore, lots of people are talking about it. Lots of people are sending tweets. Equally, if there's a shock, so again, this is more of a surprise is happening in 1 minute. Shock is happening all the way along and building up. We see that there's a positive effect of both. So if the game is unexpected, the outcome or the current situation is unexpected, there's a positive effect on Twitter activity and people talking about it. What you can see is if you look at the suspense measure, on the other hand, that tends to be negative. So it's certainly significant when we consider only the emotional cues. It's significant there and negative. And it is also when we consider that in addition with our the state of the match in terms of goals and goal difference. It then becomes insignificant in these two cases. But what we find when we're looking at a lot of these regressions at the moment is suspense is negative, and that's consistent with other work that Tim Pawlowski has done, looking at sales of refreshments in the stadium at football matches. The more suspenseful is a game, the less likely you are to nip out to go and get yourself a hot dog or another beer or something. And equally, more suspenseful as a game, the less likely you are to get your phone out and have a little look on Twitter. We can then think about the sentiment by, and I put there home fans, because this is looking at the sentiment of the home teams, Twitter users that have mentioned the home team's handle or hashtag. Similar kind of, well, not necessarily similar kind of set of results, a lot of coefficients that we're still making sense of, but we're particularly interested in the surprise, shock, and suspense emotional cues. And when it comes to the sentiment of home fans, the suspense element is negative. So this is not activity, this is instead how happy fans are, if we can treat our measure of sentiment as measuring happiness versus sadness, say. And so there's a negative effect on sentiment of suspense. So if the game is more stressful, you express the fact that you're stressed about the game, and that comes out and reflects the fact that you're not as happy as you would be if your team was 5-0 up, for example. Also, the shock measure comes out negative as well on sentiment as well, and significantly so for some of these regressions. The surprise is positive, so if it's a surprising result, it's positive. But this is just general surprise, right? Surprise and shock can go both ways. Okay, so I'm the fan of the home team, and there was a surprise when my team conceded in the 94th minute, but I wasn't happy about that. So what we actually want to be able to do is identify the fans and then change the surprise and shock so that it's the own surprise and own shock. So that I was particularly unhappy when my team conceded, and that then led to me being showing that likely in my in what I tweeted after the game. Interestingly, though, at least at the moment, in terms of very basic regressions, these are looking at home identified fans and their own surprise, is that there's not really any significant effect of either the surprise or the shock on the sentiment by actual fans of the team, rather than simply people mentioning the hashtags or the handle of the team. The suspense effect is certainly still there, so it's still significant and negative, but at the moment what we see here is insignificant effects of surprise and shock. What else? This is just to kind of make a point that the surprise and the shock, it matters whether you're looking at the own team versus the general. So this is all Twitter users, and then so this is looking at the fans. So we've identified who the fans are, and then looking at the number of tweets, and whether we look at the surprise generally or the surprise from the perspective of the team. It makes a difference in terms of the size of the coefficients. Coefficients are much smaller when we consider only the fans of the team, when we consider the direction of the surprise. So own just simply means that when my team is conceded, that's a negative surprise, whereas that might be a positive surprise if it's the away team and you're a fan of the home team. And the final thing I wanted to have a quick look at and just to flag up is that question of whether fans are different. And so what I've done here is I've just looked at the own surprise, shock, and suspense in a regression like this, stacked up all the teams on top of each other, and interacted a fixed effect for each team with those surprise, suspense, and shock terms. So in other words, if the coefficient is different for any given team, so their response to surprise, suspense, or shock is different from the generic response of all fans, that'll come out in any of these plots which plot the coefficients on these teams. Black line is the coefficient, red line is the standard error. So if the black line appears, it's bigger than, and if it's more than twice the size, that's what we conventionally think of as statistical significance. The signs, I'm a little bit unsure about at the moment what that means exactly, but what you can see is there are some differences. Now these differences tend to be, if you won't be able to see it because the writing is far too small, but they tend to be associated with what we might think of as smaller teams, the significant coefficients. So we've got Crystal Palace, which is significant here, Cardiff, we've got Hull City, who were in the Premier League at the time, Stoke City, Swansea City. So smaller, lesser traditionally successful teams. Now that could be because they are the ones that have very small numbers of tweets, but then we have taken the log transformation to try and get around that. But it could still be the fact that lots of these teams might have zeros in the data. So to wrap up, what we're trying to do here, and it's very much work in progress, highly preliminary, is we're extending recent uncertainty of outcome hypothesis work by adding in two ingredients from Twitter, which is that we can look at the sentiment of fans, how happy and sad they are, and we can identify the fan groups as well. We don't have to rely on just simply a number of the TV viewers, which is certainly an interesting measure. I don't wish to malign that in any sense, but we're able to build on that and classify fans into different groups potentially. And it appears, and again, this is a result that has corroboration elsewhere. It appears that suspense does reduce fan activity, but also fan sentiment as well. And the effect seems stronger for fans than for general observers. And fan moods appear dominated by suspense over shock and surprise. So I'll stop there. Christoph, I can see there's lots in the chat. I don't know if you want to just ask me the questions rather than I try and respond to them.
Hi Beck. So thank you very much for your nice talk. And yes, I was actually wondering about that. So the questions, they are indeed there. So I would suggest that, yeah, the easiest is probably that you simply go through them. There was the first question goes a little bit up by Carl Singleton.
Why use bookmaker?
Yeah, that one. That's the very first question. Yeah.
If people feel these things, they are likely to affect demand for risk and betting behavior, and this be exactly what bookmakers make their money from. This is the peer endogenous. Well, they're not bookmaker odds. They're betting exchange odds, to the extent that that matters. In a sense, it's not bookmakers pricing in particular kinds of behavior. And evidence suggests that they're reasonably good as a reflection of what the actual as close as we can get to the actual probability of these events taking place. So Carl follows up with, could you use instead historical match data to model probabilities of outcomes given match situation data, etc.? Absolutely, yeah. I mean, we're using Betfair odds for the moment, but we could think about others. We could try and generate our own probabilities based on past patterns, plus on regressions and so on in terms of goal arrival. We could absolutely do that. At the moment, we're using betting exchange prices. David Forrest has responded saying that that's what they did.
Yes, that's what we did, James. I don't think
David, yeah.
I don't think whatever you do is going to affect the results very much. But I think if you're to deal with reviewers, I think you need more justification for using the betting exchange because of there's a small literature on the speed of response to events on the field on the betting exchange.
Yeah.
Now, the difference between the betting exchange, which is a very small part of the betting market, and bookmakers is that the change in odds in response to, say, a goal on the betting exchange depends on the speed of response of the traders. Whereas all the major bookmakers just use algorithms which automatically change the odds when a goal is scored, and they're based on statistical models. Now, you can have various arguments because, for example, the bookmaker odds would not affect, they'd not be affected by, say, indications of pressure like you've got in your model, like hitting the woodwork, because the bookmaker is based on pre-match quality indicators of the teams, the current score, the number of minutes remaining, and whether one team has had a red card or not. And all the other action which the traders on the exchange can see, the pressure from corners and so on, don't get reflected in the bookmaker odds. But the bookmaker odds have the advantage that they move instantly on news, whereas there may be a lag of 1 or 2 minutes on the betting exchange.
Yeah, thanks, David. That's really helpful. I mean, I think we'll certainly be aiming to robustify what we do as we move along the lines that you suggested for precisely the reasons that you suggested. So that's really helpful. Thank you.
James, just a brief second before you continue.
Yep.
I just want to say goodbye because I have unfortunately another meeting. So Andreas will take over the moderation.
Okay.
Thanks again very much, and yeah, sorry to have to leave. I wish everyone.
Not a problem. Thank you, Christoph. It's good to see you online. See you soon.
Bye.
Okay, so Dennis has asked about 0 tweets, and we add a tiny number, so 0.000001 to the number and take the log. I'm very happy to take suggestions on alternatives. Just simply, so far we haven't done that.
Yeah, I think the next thing was a suggestion to use Poisson regression, probably then with a focus on zero inflation, like zero inflated Poisson. But was the response a count anyway?
It is when it comes to number of tweets. I mean,
Okay.
they can be in the thousands, but it's still a count. So I think that's a very good suggestion. So we'll definitely need to follow that up. Excuse me, Bridget says details on how definitions of surprise, shock, suspense were chosen and validated. Question about the difference between fans could lead to modeling these three feelings in an individualized way. Yeah, I mean, to be honest, we've chosen the measures based on what people, previous authors, the seminal work was the Eli et al. Paper, which I've not got in the slides because I managed to miss out the slide, but also the work with Baraimo et al. Most recently. These are the measures that they use, and they seem to accord to an intuitive idea of the three concepts. But absolutely, we could certainly think about going into more depth on each of them. And Carl says, we and others have shown Betfair exchange prices are inefficient, exactly, on surprising events. Yep, absolutely. And I think that then leads to the kind of suggestion that David's making about thinking about how the automatic responses, what they are from betting companies, and also doing modeling itself as well, about what their shift ought to be at these kinds of events. Gabor, interesting stuff. Could see the regression table did not affect R squared. Good question. I haven't spotted that. I'll have to think about that, to be honest, Gabor. But thank you very much for a challenging question.
I mean, I guess the R squared includes fixed effects, right? Because they're very high, like 96%. So maybe if you show the within R squared, that could be helpful, like comparing, because you said you have game and time fixed effects. So there's a lot of things already set out of variation and also maybe the sample sizes were not exactly the same. So there could be something, but I think it's interesting. Like, is it because if they're explained already by the events and the events kind of suck up? But even in the next column, it seemed there is very, very little change. I was just wondering if you.
No, it's a good point. Not got a chance to respond to it yet, but thank you for it.
I have a question that is probably very close to that, also on this table where we saw the regression results. I think a few slides before you showed the model. So the model was accounting also for random effects, right? Or did because I think there was a repeated measurement structure because you had an index for the time, right? So there we see the YIT. So it's okay, it's match I and minute T.
Yeah.
And the gamma T, so what is the gamma T? How can this be interpreted, this parameter then?
So that would be a kind of essentially correcting for the minute of the game. So what the average tweet numbers would be in minute 1 over the entire season, minute 90 over the entire season. So kind of correcting for that and departures from some kind of baseline level of tweets we might expect for that point in the game.
But you fit the model as a linear regression model with kind of many parameters gamma then, because you have a lot of minutes, right? Like you have I don't know, 95.
Yeah, about 100 minutes.
So maybe there you could think about just adding a spline on the variable time, maybe to get rid of all these
absolutely
parameters.
I mean, at the moment, it's quite a conventional approach in economics to add, what we call fixed effects for the minutes, or for the time dimension and the cross-section dimension. But equally, at the same time, that convention is arguably changing at the moment because there's been lots of results kind of questioning what we get from linear regression setups like this. So yeah, open to that. Absolutely. Thank you for the suggestion.
Yeah, because then you would save a lot of parameters, and you can have a very nice curve that you can plot where you can directly see what is the smooth effect of time, like over the game play time. Yeah, thank you.
Yeah,
thank you also for the nice talk, by the way.
You're welcome. Thank you for inviting me.
I see there is a few raised hands. I think Tim, maybe you was first, I'm not sure, and Dennis also.
Dennis was definitely first. So
okay, then Dennis, please go ahead.
Okay, so this is a really interesting talk. But when I think about the uncertainty of outcome hypothesis, I don't think about this even remotely, because the uncertainty of outcome hypothesis is basically about demand for attendance or demand for viewership. And if you were telling me that people were turning off the television because of this, I would say, yes, you're telling me about uncertainty. I just learned that the game is far less uncertain than I thought it was. I'm not going to watch it anymore. But I don't see what you're doing here as addressing that idea. It does. So I think that it's a very interesting topic about how people feel about the game as it's going on. But I don't think it's related to uncertainty of outcome in a fundamental way. So there's not really a question there. I hate saying this, more of a comment than a question, but that's really the idea here.
I mean, it might be that I think Tim might be a better place than me to potentially answer that question, but just to kind of give you my kind of response would be, to a large extent, this is responding to what I guess we consider as general information out there, kind of public information, and how people are responding to it. It's certainly distinct from viewership, absolutely. It's a different way that people express how they feel about particular events, and there's no kind of, there's certainly no willingness to pay or no kind of recorded action take on the basis of this, which is always the case with social media data. But it also tells you how people are responding, kind of, if you like, in abstraction from that, to these kinds of events, and you presume therefore that that is likely to impact how people express that desire or otherwise for uncertainty, and through these emotional cues of suspense and shock and surprise. But I might appeal to Tim, since he's already got his hand up, to perhaps respond to that.
But not to ask or to answer too difficult questions, probably. But anyhow, yeah, that's a valid point, of course, Dennis. And I think ideally we would even go further or beyond and merge what we have at the moment, maybe with TV viewing figures at a minute basis. So somehow trying to combine what David and Babatunde and colleagues did before in their paper in combination with our approach here, because I think in a way, the very nice twist of the story that we try to offer here is that we can identify fans, and you can't do that just with the TV viewing figures. But now, of course, moving beyond and trying now to figure out how, let's say, more harder measures of demand would evolve is really and clearly very interesting, and I think somehow the next step. We haven't clarified at the moment if we can purchase somehow these TV viewing figures, but that would definitely lots of value, I guess. Still, I would argue that we have a measure of interest, if you want, and I would not disregard it as being, let's say, without any value. But what we cannot say for sure is, for example, if people who are tweeting are moving away from other demand actions. So if, for example, they are less betting and more tweeting, or if they are more betting and less tweeting, or if they switch on TV, switch off, or something like that. But what we should keep in mind is that they need to somehow keep being informed about the game. Otherwise, you cannot tweet, right? So people could just respond to other tweets in any chats. But I think it's more likely that people are somehow following the game online, maybe on TV or wherever, and then they respond. And so I think we need to be much more, let's say, clear about what is the dependent variable in this regard, and what does it measure. My very brief follow-up on the comment by Andreas is, this is a great idea, actually. And at the moment, we are just modeling everything linearly. And I think we have, for example, talked about generalized additive models, which is very nice, because there you keep additivity, which means interpretability of the coefficients, but at the same time you have flexible functional forms. And it would be very interesting to see what happens actually if we move beyond this linearity. And so, yeah, we definitely want to follow up on that. And my final word, and then I close and leave over to David, because it's actually related to what David was mentioning in the chat as well. Actually, for simulating the probability of scoring in the next minute, we were using also exactly the ingredients that you were proposing with your colleagues in the paper. So modeling it based on past scoring probabilities of the teams in the Premier League, and also considering events like red cards and so on. So that's a kind of combination measure, but for the pure Qs at the moment, we are using the exchange odds, as James has said. Okay, so now David.
Thank you, Tim. Forgive me if I take up a couple of the comments that have been made and throw in my money's worth. I would agree with Dennis that I don't really recognize this work as being about the uncertainty of outcome hypothesis, which is all about ex-ante probabilities driving attendances. And I'd caution against selling it on those grounds. You might say, well, why does he go on in his paper about the uncertainty of outcome hypothesis? At the risk of offending someone who's present, this was a requirement of the reviewer for the paper to be accepted. We didn't initially have the uncertainty of outcome hypothesis in the paper at all. The second thing is growing out of what Tim said, which is the relationship between the work that we did and the work that you're doing. I think they are linked to the extent that in the television audience paper, we observe, for example, that people who, a large number of people will start watching the game when there's been a big surprise. And where surprise occurs is usually a goal. And I remember Brad Humphreys telling me at a seminar, this is nonsense because they're not watching, so how would they know there'd been a goal? Well, I thought that it was pretty obvious that there would be other ways other than seeing the game on television. And a primary mechanism for informing the prospective television viewers would be the receipt of tweets from friends. So there's a complementarity between the activities that are being observed in our paper and in your paper. Now, the last point I want to make, forgive me for going on for so long, is that I'm very interested in what you're doing. It's interesting for its own sake. I'm less sure over whether we can go the next step and figure out how much utility is being generated by different elements of the game. Because the results, in a way, are tautological. It's preordained that surprise will appear as more important than suspense if you look at the coefficients. because surprise takes on a high value when something happens. There is a trigger to making the tweet. Suspense, in fact, something happening can actually deflate suspense. A team might be 1-0 up and then it goes 2-0 up with 5 minutes to go and the suspense is gone. But if the match is going along full of suspense, it really matters what happens next, but nothing does happen. There is no prompting of you to give a tweet. Indeed, some of the tweets will be mechanically responsive to surprise. For example, when my local cricket team is away and I can't go to the match, I will look at the Twitter feed from the local newspaper journalist, and he will automatically post every wicket that falls. That's when he posts when there's been a wicket. And if presumably the football reporter will tweet when he's got a goal to report, which is always going to boost the impression that it's surprise that matters rather than suspense. The suspense is unproductive of actions. Those are just some general thoughts.
No, thank you, David. Really useful. I don't think I've got any immediate responses to them, but I think they're very good points. And Gabor's put in the chat that there's some way of suggesting that what we've had with the social media is the intensive margin, and TV views is the extensive margin in terms of a reaction, since you might then decide to switch the TV on because of what you've seen on Twitter. Absolutely. And good points about suspense as well. I mean, I can naturally understand why you wouldn't tweet if something is suspenseful, just because your attention is on the action itself rather than, you grab your phone out of your pocket and you have a look at what's going on. So, yeah, thank you.
I think there is first one was Dennis, and then Georgios.
Yeah, thinking about what David just said made me think about the sources of the surprise versus the suspense, and putting it in a context of a different sport. I know you have football matches, but I think about American football, for example, where penalties or the lack of penalties can have very strong impacts on people's reactions to the game. Whereas a foul called in a football match is largely irrelevant. I mean, they do almost nothing. Whereas the similar sort of thing in an American football match could have quite a substantial outcome, influence on the outcome. And so therefore have more influence on either surprise or suspense. In fact, I tweet during American football games all the time, and it's often what you might think of as a non-event. So somebody doesn't catch the ball thrown to them. I can't imagine anybody really tweeting about somebody not controlling a long pass kicked to them in a football match, or not very often. And so I wonder if maybe European football or soccer isn't really the best place to try to test this. And just, I don't know if you can get different sports data, but I think that might be an interesting thing to consider.
Yeah, thanks, Dennis. I mean, you also made me think about something else, which is that we're at the moment looking within the minute. Whereas I know if I tweet about something in a football match, it's often a few minutes later. and you're responding to events that have happened a few minutes ago with other people that are fellow fans on Twitter. So yeah, I think there's certainly something there, and also the way in which we might capture the response to these different kinds of events.
I think now Georgios was next.
Yes, thank you very much for the very interesting talk and I think very insightful also results. I was wondering myself the same as David and Dennis, considering what exactly your variable is capturing, your dependent variable is capturing. And I was thinking perhaps what you capture is consumer viewing and attention behaviors. So if you are watching a game when, so to say, your opportunity costs to take off, to use your phone are lower. And there is some research on this, which shows, for example, I just posted you a paper, which is a working paper, which actually says that when you are actively watching a game, you care more about suspense than you care about surprise. And I think this is somewhat also captured in your results. And what puzzles me, because this is something that you could solve, is that I think that you have tweets from all over the world, right? Or these are just UK tweets?
All over the world. There's no geographical restriction.
Okay, because if it was just UK tweets, you can just perhaps exploit the fact that some games are televised and other games are not televised, and see what's going on there. But the fact that you have tweets from all over the world makes this more complicating, because there are some countries where all the games are broadcast.
Yeah.
Is there any way to get only UK tweets, or to find the origin of the tweets?
From recollection, about 2% of tweets apparently include, at the time included, the location at which they were sent. So a tiny fraction would be able to get the information on where they were sent, I think. My sense is that, well, we could look at which games were televised, and it might well be then that you would see differences in tweets, because although, yes, these teams have fans all around the world, possibly the case is that if Cardiff City are on TV, then you will see a big effect, because there won't be many Cardiff City fans around the world tweeting, and they'll only tweet, or therefore the effect of it being televised will be much more clear in the data.
Mm-hmm.
But no, thank you for the paper. We'll certainly follow up on that. And thanks for the comments as well. Good to see you.
Okay, so thank you so much, everyone, for this very fruitful discussion after this nice talk. I think the two hands that are now still there are leftovers, I guess. Are there any other questions that are still there and urgent? I see David is posting something in the chat. I think it's more like a remark. I don't know, James, if you want to comment on that as well.
No, I think it's a good point. I mean, I think the point to you look at different sports again is a great one, and it's one of those things where we'd like to have the data to do so, I think, and there's the scope now, because you can get Twitter data for free. Back at the point when we were collecting this, it was quite expensive, but now you can register and you can download tweets. So there's lots of potential there for research on different sports, and differing nature of play, the differing nature of scoring opportunities, all means that different games have different characteristics that are potentially quite interesting for trying to look at the kinds of things that we're looking at in our paper.
Perfect. Thank you, James, again.
Thank you.
Yeah.
Thank you, everyone.
I think this was a very, very fruitful session today, and I'm glad that we have it on video. So as I said, I will now stop the recording